Hello and welcome to kind of a continuation of the nervous system video lecture for the special senses. So there are many special senses in the body. Most people know about quite a few of them, right? Taste, smell, sight, sound, touch, right? We have heat receptors, we have pain receptors. Those are all special senses. We are going to talk about, equilibrium, that's another one. We're going to talk about two of the organs, the special organs responsible for special senses. So the first one we're going to talk about is the eye. The eye is an amazing, beautiful, and wonderful organ. I'm so excited to tell you guys about it. So I've drawn for you a little kind of diagram here that's like a side view cross section of an eyeball. I'm going to give you a couple definitions on the side here. So palpebrae is the eyelids, and the eyelids have cilia, which are eyelashes. So that's not really pictured on this diagram. We just kind of have the eye here and its surrounding parts, I guess. So those are two kind of things that we're not necessarily showing you in this diagram. So let's say out here we got a nice little, apparently I cannot draw a light bulb. It's a light bulb and it's shining. This is an old-fashioned light bulb. I think these kind you can't even really buy anymore, the incandescents, but it's okay. I'm fine with it. Anyways, we have a light bulb out here. It's shining light. So I'm going to kind of tell you the story of the eye and how it processes what it's seeing in order going in here. Okay. So the very first thing that light passes through is this outermost layer, and that's called the cornea. So the cornea is the outermost layer of the eye. So if you touched your eyeball right now, you'd be touching your cornea. If you wear contact lenses and you put them on your eye, they're going on top of the cornea. So for going further in here, next the light's going to pass through this section here, which is aqueous humor. Humor is just an old-fashioned word for fluid. All the fluids in the body used to be called the humors way back when. And this is located in the anterior chamber. And this aqueous humor is very watery. And that makes sense, right? Its name is aqueous. Aqueous sounds like aqua. Aqua means water, right? So the aqueous humor is watery. It's in this anterior chamber, which is just means like the front chamber. And it makes sense that we want this fluid to be watery because light needs to be able to pass through it, okay? So next the light is going to enter the pupil. So when we look in our eyes, it kind of seems like the pupil might be this solid dot, but in reality, it's actually just a hole that opens up into the back of the eye. The size of the pupil or the size of the hole is controlled by the iris. The iris is the colored part of the eye. So like in cats with beautiful green eyes, their iris is green. Dogs with that rich brown, that's their iris, okay? So now that light has passed through the pupil, it's going to pass through this guy, which is the lens. The lens is held in place by these little ligaments. And it is possible for this lens to be knocked out of place. So that's kind of a serious issue if that does happen. But in theory, you know, if you don't get hit hard in the face with things, then that shouldn't really be a problem for you or your animals. So the lens is actually a pretty hard piece in the eye. It's like a hard piece of glass, and what that lens does is it serves to focus the light back onto here, which is the retina. Okay, so the retina is really quite interesting. The retina is what has rods and cones. So rods and cones are the things that are responsible for taking in and changing that information into something that the brain can understand. So rods process light, cones process colors. You don't need to necessarily know this for the test. I just think it's interesting to know, and people tend to enjoy learning this part. So I'm sure right now you're thinking, whoa, 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 colors? I heard that dogs and cats see in black and white. And that's only partially true. They can definitely see black and white. But in comparison to humans, so humans have 3 different types of cones that can see and understand all the colors that we see and understand. Dogs and cats only have 2 of those cones. So they lack the cone for red. So I'm gonna write red here. I'm gonna scratch it out. They don't have the one for red. They can see blues and yellows. And then obviously whites and blacks and grays. So they can't really process red, and they don't see greens very well. Greens they kind of just see as a gray. So it's certainly a lot more kind of a muted color palette that they can see and enjoy. So, you know, we're walking through the forest and see these brilliant, beautiful green leaves and trees and grass, and they're just kind of like, hey, cool, there's a yellow squirrel over there, right? So they don't really appreciate or see all the green or red. So that's the retina. That is responsible for making sense of that light coming through the eye and sending that information through the optic nerve to the brain. So the brain makes sense of the information sent by those rods and cones, and then we react to whatever we're seeing. So there's a couple more things that aren't necessarily involved in that passage of light that I want to touch base on. One is the vitreous body or the vitreous humor. This one is very gel-like, which makes sense because this vitreous body, it gives structure to the eye, okay? So it makes sense that it would be thicker, more like a gel, versus this watery fluid that's up here. And this is located in the vitreous chamber. So that's easy enough to remember. Vitreous body in the vitreous chamber. I guess I should put in. And then, so the cornea is continuous with this part of the eye here, you can see. So cornea is the front part, and it's continuous down here and up here. So that part is called the sclera. The sclera is the whites of the eye. Okay, so that's the part of the eye that appears white. And then in between the sclera and like the retina, we have the choroid. I'm going to draw this line a little bit lower. And the choroid, that contains all the blood vessels in the eye. Okay, and then last but not least, I'm just looking to see if I have a red pen kicking around, but I don't. This kind of wiggly part of the eye, if I had a red pen, I would color that in red here and here. That's the conjunctiva. So this conjunctiva is continuous with the like eyelids that would be out here, and then the eyelashes coming off that eyelid. So if you flip down your eyelids, you'll see all that redness and all like the inside of your eyelids, and that's the conjunctiva. If you get pink eye, it's called conjunctivitis. It's inflammation of that conjunctiva, and that is what's causing all that redness in the eye. One other thing I just want to mention, just because I think it's a cool thing, it's not like for the test or anything, but there is a interesting thing that animals have, lots of animals have, that humans do not have. So think about like if you've ever been camping, or if you're like driving down a road in the dark and you can see eyes glowing from the side of the road or behind your tent or something. So animals have something called the Tapitum Lucidum. So I'm just going to spell it for you here. But again, it's not on the test, so don't think you need to memorize this. So this Tapitum Lucidum, it acts as like a reflective strip kind of inside the eye. And that's what allows animals that can see in the dark, that's what allows them to see in the dark. So it's reflective, it reflects back out to us, but also it reflects back in here so that it makes the eye think that there's more light than there is. So not only does it reflect back out, so we're seeing the reflection, but it increases the amount of light inside the eye, which gives them better night vision. So I just think that's a cool fact. So I like to share that one with you guys. So that is the eye diagram. We do have a practice activity that involves you labeling this diagram. I strongly encourage you to do it. Just speaking in the by and by, on your test, you'll have to label a diagram. Just saying. Okay, so this is a picture of the eye then from the side, right? So we've seen the side of the eye. I want to draw another picture of the eye to give you some information about the lacrimal system in the eye, which is what makes the tears, okay? So this is the lacrimal system of the eye. I'm going to reference a figure in your Elsevier, but it's not really the lacrimal system. Honestly, it's just external eye anatomy, but that might be a good one for you guys to have a look at just to kind of get an understanding there of some of the external anatomy. I also realized I didn't reference the figure here. So figure 4-23, page 93. So I'll leave that like that for you guys to see. Okay, so the lacrimal system. So now at this point we're looking at the eye head on. So we're facing the animal face to face. So this is the eye. I'm not getting into any more detail than that on the eye. So the eye has a third eyelid, which I'm sure you guys have heard about, right? In dogs and cats, they have this third eyelid that will kind of come up and like creep across the eye. If your pet has ever fallen asleep with their eyes kind of partially open, you'll see that like usually covering almost the entire eye. So that third eyelid is called, third eyelid equals the nictitating membrane. So the third eyelid is the nictitating membrane. That membrane has a gland on the inner surface. That gland is called the third eyelid gland. And I can't draw it into this diagram for you because it's underneath that third eyelid. So the third eyelid gland is on the inner surface of this nictitating membrane, okay? So I can't draw that in. I mention that because it's an important anatomical thing to know, because lots of dogs have problems with that gland and it will prolapse out of the eye. If you've ever heard of cherry eye in a dog, that gland has prolapsed, which means it's sticking out of the eye all the time. It looks red and like squishy, kind of like a cherry, which is why it's called cherry eye. Okay, so let's get back to our drawing here. So this is the lacrimal system. Lacrimal means tears. So this is how tears are produced and kind of filter through the eye here. So we have our lacrimal gland up here. So the lacrimal gland is what produces the tears. So the tears are produced up here. Oh, just for a side note, this is medial. This whole side is medial. And this side is lateral. Okay, so this is more to the side. So we talked about that medial canthus when we were talking about the reflexes. The medial canthus would be over here. Okay, so the medial canthus is in the middle, more towards that midline. So tears are produced in the lacrimal gland and they travel across the eye. Okay, near to that third eyelid, we've got these little guys here, which are called the lacrimal puncta or punctum. So punctum is singular, puncta would be both. So there are two, and then those guys drain into the lacrimal canals. And that fills up the lacrimal sac. And then that drains via the nasolacrimal duct. So using our really cool word parts, nasolacrimal duct. Well, we know it involves tears. Where do you think this duct drains with a root word like naso in it? It drains to the nose. So the nasolacrimal duct drains into the inside of the nose. And you guys probably deep down already knew that. I'm assuming you've cried at least once in your life. Every time you cry, you know how your nose gets all runny? That's because there's tears in your nose because they're draining into that nasolacrimal duct. So again, this is an important thing to know because as a VOA, you often are the last point of contact for owners before they leave the clinic after having seen the doctor. And like probably really close to 100% of the time, you guys are the ones answering the phones when clients have questions. So there is a test that we do on animals called the Fluorescein Dye Test. So if we suspect that the animal has a scrape on their cornea, so like that outer layer of the eye, if we think that there's some kind of damage to the cornea, we can't necessarily readily see it. So what we do is we put this dye into the eye that's like the color of yellow highlighter. It's really bright yellow. And then the doctor washes it all out and then shines blue light in the eye. When there is no damage, the eye just looks normal. There's nothing there. But if there's damage to the eye, the damage uptakes that dye, and when you shine the blue light on it, it glows, and you can see exactly where the injury to that cornea is. So why is this important? Why do you guys care about this? You care about this because when we've put dye into the eye, it's gonna drain into that lacrimal punctum. It's going to enter the lacrimal canal, fill up that lacrimal sac, and it's going to drain via the nasolacrimal duct directly into the nose. And then the owners are going to say to you while they're waiting to pay their bill, "Oh my God, now he's got something wrong with his nose. There's all this yellow stuff dripping out of it." Or maybe they'll have gotten home and they'll call you in a panic, "Oh my God, yellow stuff in the nose." And you'll be able to say, "Actually, that's really normal," and you'll be able to explain about this lacrimal punctum canal sac and nasolacrimal duct. So you'll be able to say, actually, tears from the eyes drain into the nose directly from the nasolacrimal duct, and that's really normal. So congratulations, your pet's ducts are functioning properly, right? So that's a good thing to know, to be able to share that with owners, right? Okay, so that's everything I wanted to share with you for the eye. But I do want to talk about the ear next. So I'm just going to flip my sheet here and we're going to talk about now the ear. So the ear is responsible for two senses. Responsible for hearing, obviously, I think we know that one already. And it's responsible for sense of balance. And the fancy word for that is equilibrium. So let's talk about that guy. So I'm going to draw a little picture here for you. Okay. Okay, so this is, again, a pretty loosely interpreted drawing of the ear. So you can see the ear canal, page 92, figure 4-22. I feel like I put some good diagrams in the notes as well. I honestly can't remember. I feel like I put some pictures in there though. Okay, so the outermost portion of the ear we know from our external anatomy is called the pinna. So that's everything that we can see outside of the ear. So then, so look, dogs are cool. Dogs and cats are really interesting. They have these L-shaped external ear canals. So our ear canals just look like this. They just sort of have that sideways thing. So if you put like a Q-tip, here I'm going to do this one. If you put a Q-tip in there, you run the risk of hitting this, which is the tympanic membrane or the eardrum, right? So that's dangerous in humans. Well, it's dangerous in any animal. Rupturing the eardrum is really painful. You can end up with ear infections in your middle ear, your inner ear, and you can lose your hearing altogether. So that's not a good thing. So we need to be careful with that. Dogs and cats, though, have this really awesome L-shaped ear canal, which means that we can get pretty deep in there when we're cleaning ears, and we're not running the risk of rupturing that tympanic membrane. So we can tell owners, you can put your entire finger into that ear and you will not hit that eardrum. I still, though, do not want to recommend to owners to use Q-tips in the dog's ears. It's okay to use Q-tips to like clean all those little, whoops, you know they have like folds in the ears, those kind of weird little folds. Yeah, sure, use a Q-tip to clean up in there, but do not ever put a Q-tip into the ear, because all it takes is the dog to shake its head and then we lose that Q-tip in there, and then you have to bring him into the vet and we have to fish it out with special instruments. So I'm just like, oh, responsible. I was like, what the heck was I writing here? This looks so messy, this word, responsible. So anyways, we don't want them to use Q-tips in the ear because we do run the risk of losing them in there. So this portion of this L-shaped ear canal is called the vertical canal. This part is called the horizontal canal. And collectively, they're known as the external ear canal. External ear canal. So then we come up to the tympanic membrane. The tympanic membrane is the eardrum. So the eardrum acts just like a drum. So maybe you guys know this already, but sound travels through the air in waves, right? So, you know, think waves like this, and they bounce and bounce back off of things. So they travel into the ear, these waves, they bounce off the tympanic membrane and kind of travel back out. But once they've hit that tympanic membrane, it causes like a drum, right? Like that resonance. And then this eardrum articulates with a bunch of tiny bones. You don't need to know the names of the bones. Pretty sure I put a diagram in your notes, though, of those bones if you're interested in what they look like. So once that tympanic membrane is hit, it causes those bones to all interact with each other, and then that sends messages to the brain about things that you're hearing, okay? So we need this tympanic membrane to be intact, right? If it is ruptured at all, hearing's going to be compromised because it's not going to interact with those little bones. And then also this tympanic membrane serves another function, and that's keeping this inner ear or middle ear, keeping it sealed off from the outside world, okay? We don't want stuff from the ear getting inside the middle ear. They can cause a lot of inner ear infections, which are way tricky to treat, and it causes a lot of pain in the animal. Also, if you have things going on in the middle ear, it can really mess with the animal's sense of balance or equilibrium. So the middle ear is filled with all these tiny little hairs. I didn't really draw these hairs great. And there's fluid in there, okay? So the brain picks up information from all these tiny little hairs, and those hairs tell the brain what position the body is in, okay? So the body is standing up, that fluid's at a pretty steady level. We can understand that we are standing up because only the hairs that are down here are being triggered, okay? Think though when you spin around, like maybe you've been on a ride or you've just spun around for fun as a kid and you get really dizzy, right? That like swirling feeling, you have no idea which way is up. That's because while you're spinning, it's causing all this fluid to jostle around, right? So picture like I've got a glass of water here, right? So you're like spinning, that fluid starts doing this. It's getting all wacky and weird, right? That wacky and weird fluid is now tripping all these hairs all over the middle ear. And the brain is like, what the heck? I can't make sense of any of this. And so you have that really disoriented dizziness feeling. So that's that feeling of equilibrium, and the middle ear is responsible for that. So lastly, in the middle ear, we've got this little tube. It's called the Eustachian Tube. This guy is responsible for equalizing air pressure in the middle ear. Middle ear. So this guy drains to the nasopharynx. So naso referring to the nose, pharynx is like the back of the throat. Okay, so it's like kind of drains to that area. So I'd like you guys all to take a minute with me right now and yawn. Can you feel little pops and cracks in your ear? That's because your Eustachian tube is doing its job. If you're not hearing the pops and cracks, it's either pretty equalized or maybe you're stuffed up or have a cold or something. So this Eustachian tube, while you're yawning, opens up and equalizes the air pressure in and out, okay? So when, think about when you're on an airplane. Assuming you've flown before. If you haven't, I'm sure you've heard about people talking about their ears popping on an airplane. So what's happening there is that the air pressure on the plane, honestly, I can't remember if it's higher or lower than usual. I'm guessing lower because you're going higher up in the air. I'm pretty sure it'd be lower then. But anyways, the air pressure out here is now lower, which means that this tympanic membrane, it's a really thin membrane. It's gonna bow out. Okay, so whereas usually should be straight, it's bowed out because here the air pressure is higher, so it's putting more pressure here into the lower pressure area. We need to open up that Eustachian tube to let the higher pressure here out so that this can go back to normal. If you've been on an airplane and you haven't been able to equalize that pressure or get your ears to pop, then what happens is like your hearing feels really muffled, right? I find it's difficult to hear on an airplane. And that's because, well, sound waves are coming in here, but this drum is so taut, it's like just bouncing off a wall. It's not really able to send those messages to those little brain, or those little bones, which send the message to your brain the way it should, because it's just too taut, it's too tight. We want that nice, usual kind of pressure there where it's nice and flat. So the Eustachian tube is what serves that purpose, to equalize the pressure there in the middle ear. So the ear, responsible for the sense of hearing, responsible for the sense of balance, I think seems like a fairly straightforward and easy, organ, but I think just super fascinating. Same with the eye. I love our special senses. I think they're really interesting. Although I think I say that about all the systems so far that we've talked about. I'm like, I love this one. It's so interesting. Okay, so... Oh, I don't have specific pages. Oh, no, I do. Never mind. Elsevier is pages 90 to 94 for the special organs, the special senses. And in your McBride book, it's chapter 15. So, like I said about that eye diagram, I do really, really encourage you to do that practice activity on labeling that side view of the eye. There is a diagram on the test. It could be any of the diagrams we've talked about, but I feel like if there's a practice assignment for one of them, really focus in on that one. Also, I do have the practice activity for the eye and the ear, so you can go over that one as well to engage with the material and interact with that and learn it well. Okay, so if you have any questions, do make sure, please, to ask them in the virtual classroom, in the chat, or send me an email. As always, I'm super happy to help. Okay, thanks so much for listening to this lecture. I hope you found it as interesting as I do. I hope I've sparked some of my passionate love for anatomy and physiology. Okay, thanks everyone. Bye.